So now that you've reviewed limits on Khan Academy, we're going to start filling out the notes on page 168 in your note guide, 11.1. A limit is how the output of a function, and again, output is f of x or your y values of a function, behave as the input or your x values approach some value. The notation of it is the limit as x approaches c of f of x is how you read that. In this example, we're going to use the table to find the limit as x approaches 0 of the sine x over x. So in order to do that, if you wanted to graph that on your graphing calculator, then all you would need to do is go to y equals, put in sine x divided by x, go to window, make sure that you're in radian mode, and then go to window, and you can change your window to negative 2 pi to 2 pi, count by pi over 2, and your y values negative 2 to 2. Then if you hit second table set, you're going to change under independent, you're going to change the auto to ask, and then go to second table, and now you can type in these values on your table. So what we're looking at here is we're looking at what is happening to the values as I approach 0. So first off, we're going to start from the right-hand side of 0. And when I plug in 1, f of x is 0.84147. So when x, and again I'm moving to the left towards 0, when I plug in a half, f of x is equal to 0.95885. When I move even further left towards 0, 0.1, I get 0.99833. And what happens when I put in 0.01? I get 0.9998. So you can see how close, the closer x approaches 0, the closer y is approaching the number 1. Now, if we were to do the same thing from the left-hand side of 0, you could start with negative 1, and you get 0.99833. If I move now to the right towards 0, 0.01, you can see 0.9998. And so even though if I were to plug in 0, f of 0 is going to be undefined because you would have 0 at the bottom of that fraction. But the limit does exist, and the limit is what the graph is approaching from the left side and the right side, which happens to be 1. So the limit as x approaches 0 of the sine x over x is equal to 1. If you go ahead and hit graph, and you graph that function, you're going to see something that looks like this. Now when it hits 0, there would be an open circle, and then something like this on the other side. And it's not super symmetric, but I think you get my idea. As I'm moving in from the left towards 0, as x is moving in towards 0, the y values, or f of x values, are moving closer and closer to 1. And as I'm moving in from the right side, as x is moving towards 0, the y values are moving closer and closer and closer to 1. In example 2, we're looking at the limit from a graphical approach. So the limit as x approaches 2 of x squared subtract 4 over x squared subtract 2. So the first thing you're going to do is go to your graphing calculator, go to y equals, and graph x squared subtract 4 divided by x subtract 2. And instead of hitting graph, hit trace. And you are going to trace along the function. And what I want you to see is as we are approaching x equals 2. So here is x equals 2. As I am approaching from the left-hand side. I'm here, and then at 0, I'm here. And you can see as I am moving towards x equals 2, what is f of x getting closer and closer and closer to? So you can see when I hit 2, I'm undefined. So f of 2 actually is undefined, but the limit exists because the limit is what are we approaching. And so if you follow this across, it looks like we are approaching 4. And you can also see that from the other side. So from this side, here is x equals 2. And if we follow this function, so when x is here, when x is here, f of x is up here. When x is here, f of x is up here. And as I am moving in towards, so I'm moving in towards x equals 2, what is f of x approaching? And if you look here, even though we're undefined here, f of x is approaching 4. So the limit as x approaches 2 of x squared subtract 4 over x minus 2 is equal to 4. One thing that's important to note is the limit only exists if from the left side or the lower bound side and from the right side or the upper bound side we are approaching the same value. So you see that we're approaching 4 from the right and we're approaching 4 from the left. And so therefore the limit exists and the limit is 4. Example 3 is finding the limit by direct substitution. So far we have found the limit by using a table, the limit by looking at the graph, and now we're looking at the limit by directly substituting in the value. Now this process is the easiest if you can get it to work. So looking at this, it says the limit as x approaches 2 of this function. So all we're going to do is we're going to plug in the value of 2. So the limit as x approaches 2 is equal to 2 squared subtract 2 times 2 plus 8 over 2 plus 2. So if we go ahead and simplify that, we get the limit as x approaches 2 is equal to 4 subtract 4 plus 8 over 4. And this is going to equal 2. So the limit, we could say the limit as x approaches 2 of f of x is equal to 2. And f of x is referring to this function right here, x squared minus 2x plus 8 over x plus 2. In this example, the limit as x approaches -3, we can't direct substitute to start with because -3 plus 3 would give us 0 in the denominator. So before we use direct substitution, we are going to want to factor the numerator. So that's a difference of 2 squares, 3 plus x and 3 subtract x. And the denominator is x plus 3. And again, this is the limit as x approaches -3. So you can see that the 3 plus x and the x plus 3 are going to cancel. So now we've got the limit as x approaches -3 of 3 subtract x. So we can go ahead and directly substitute at this point. This is going to give us 3 subtract -3, which will equal 6. So the limit of this function is 6.